Welcome to everyone to our Friday talks. Today we will have Juan Carlos Ramon and Cesar Mora into the Guajira Onshore and Offshore mega area, different exploration opportunities. Juan Carlos is graduated from Universidad Industrial de Santander in 1988. He's got a professional degree in geophysics from Colorado School of Mines. He's got as well a PhD in geology from Colorado School of Mines. Into his extensive working career, he has worked for ARCO from 1996 to 1997 as exploration geologist. He has worked as well for HOCOL from 1998 to 2004 as exploration geologists and new ventures. He's worked in BP in 2005 as a development geologist. He has worked in Emerald from 2005 to 2015 as exploration vice president of reservoirs. He has worked as well in Ecopetrol from 2016 to 2018 as vice president of assets and partners. And he got 12 publications in international journals. And as well, I like to introduce Cesar Mora, that he has been with us in many talks, and he's a geologist with more than 33 years of experience in basin analysis and prospect evaluation, play concept assessed, petroleum system modeling, petroleum geochemistry, and yet to find assessment. He's been involved into regional studies in Colombia, Ecuador, Peru, Chile, and Mexico, working for companies such as Ecopetrol, Cipetrol, GEMS, and Cuenca. He's been as well a professor of petroleum geochemistry and basin modeling. So I like to give a warm welcome to Juan Carlos to this interesting talk, and I hope all of you enjoy this.
Good morning, everybody. Are you seeing the presentation okay, I hope? In the next few minutes with Cesar, what we would like to share with you guys are the results of a regional study that we pursue with a group of around 13 professionals in the Guajira, including the onshore and the offshore portions. We will share the geological integration, the analysis of the petroleum systems, and of course the prospectivity in the series of frontier basins that we pursue with the ANH. At this moment, we would like to thank ANH for the invitation and to participate in these projects. The main topics that we are going to share in the following minutes are a quick summary of the main findings that we had in the area. Then we're going to show you the tectonostratigraphic provinces and why we identify them and how they control the tectonic and the stratigraphic evolution on the area. Then we are going to show you the stratigraphy and the distribution of reservoir and seals in the area. And finally, we're going to cover the multiple traps that are the exploration potential in this area. And at this point, I'm going to give the control to Cesar, that he will share with us the petroleum system modeling, the play fairway analysis and modeling, and of course, the yet to find volume and resources. The study area, as we mentioned, includes not only the onshore, but also the offshore and the huge marine platform that is in front in the northernmost Colombia. We integrated in this study close to 45,000 kilometers of 2D seismic. Most of the seismic is relatively good quality. as you might expect for marine data. And we integrate also the existing 42 wells that we have in the area. Of course, for the dimensions of the area, the well coverage is rather very sparse. And of course, I mean, classifying this basin as a frontier, and still a lot of exploration potential to find and to define and to develop. The main findings that we would like to share with you today are that we divide the area in 3 tectonostratigraphic provinces that you will see why we define those. This area is controlled essentially by the complex tectonic history that is associated with the interaction and relative movement between the Caribbean and the South American plates. And in the area, although some studies show differently, we found no evidence of subduction processes. The area is a complex evolution, mainly from the accretion and the development of a series of different generations of basement in the area, that of course the tectonic interaction of this one affect and control the distribution of the sedimentary sequence and the main development of the reservoirs in the area. We identified locally across the basin the preservation of Cretaceous and Eocene sequences that have a huge exploration impact in the exploration potential in the area. Deposenters, sedimentary deposenters generated by differential tectonic activity control the stratigraphic changes and the filling and the distribution of reservoirs, and of course source rocks and the development of traps in the study area. The presence of multiple hydrocarbon shows in most of the wells suggests active migration processes. We identified and summarized the main characteristics of good reservoir intervals that are present in most of the wells drilled in the basin, highlighting that the Oligocene and the lower Miocene sections has the best exploration targets. We identified abundant and multiple types of traps, both structural and stratigraphic, that are distributed across the basin, indicating that we have a lot of unexplored potential in the area. It is worth to highlight that the northeasternmost onshore Guajira, in the extreme of the peninsula, is connected with the Gulf of Venezuela deposenter that contains the prolificous Cretaceous source rock, indicating a possible huge potential for exploration in the area. The petroleum system modeling indicates that the Cretaceous source rock reach hydrocarbon generation and expulsion within the study area. Also, the petroleum system modeling results explain the hydrocarbon that are found in the basin and the thermogenic hydrocarbon manifestations that are repeatedly reported in different piston core data, and indicate that there is a higher possibility of finding liquid hydrocarbons in the north part of the Guajira offshore basin, mainly associated with the Chimadi and Urumaco deposenters. Going into the data, we want to, show regionally this Bouguer free air anomaly gravimetry map that was published by Londoño in 2015, showing in red the abundance of paleo highs in the area, that regionally these paleo highs control the distribution of the position of the sedimentary sequences and control the tectonic evolution in the area. If we go into detail into the study area, this is a seismic attribute map from the most shallow part of the seismic data. And in this one, what you might see is that there are clearly shown a lot of structural features, that are present in the very shallow part of the seismic section, of course, evidencing that the tectonic evolution goes until very recent times. Also in this section, we want to share the three tectonostratigraphic provinces that we define in the area that go from the south in the Provincia Chirrinche, what we call Chirrinche Province, in the middle section, the Tayrona, and in the north and east part of the section, we have finally the Chimadi Paleo Center. If we take a look of a regional seismic line, or a regional composite seismic line, I should say, going roughly from the east, northeast, all the way to the west, southwest, what you can clearly see is that we have a central portion of the basin that is characterized by huge paleo highs, basement paleo highs, that restrict the deposition only to a very shallow section and the most recent tertiary section, while toward the east and toward the west, we have big depositors that allow the preservation of a sedimentary sequence that goes all the way to the pre-Eocene, and in local areas, the preservation of Cretaceous sediments within the study area. If we take a look of the boundaries between these tectonostratigraphic defined provinces, this is an example of a line that is roughly east-west that shows the dramatic contact that we have between the Chimadi Province that is displayed in the right and the Tayrona Province that is in the left of the image that you are seeing. You might see in the middle the big structural feature that is the Chimadi Fault, that although it has a very strong strike movement component, you might see that from this seismic line that it has a vertical movement quite significant, around 3 seconds in two-way time. If we move to the southern portion of the study area, the other boundaries are defined by the well-known Cuisa and Orca strike-slip fault that are believed to have sinistral movement. Here are two examples in north-south to the seismic lines where you might see the character of the Cuisa fault, that it seems, a rather small fault with no strong deformation as evidence in the 2D image. However, the strike-slip movement has been clearly documented and published in several papers that goes all the way from 35 kilometers to up to more than 100 kilometers for the Orca fault. Then if we take a closer look of the different stratigraphic provinces, we start in the south. The southernmost province is what we call the Chirrinche Province. This province is characterized by a very wide marine platform, as you might see in this north-south 2D line, essentially deformed locally by the strike-slip major faults of the Orca and Cuisa and all their branches, and from local extensional or normal faults developed associated with this, with the extensional regime that these two faults create in the area. Also, it is worth to highlight that toward the base of the basin, toward the base of the sedimentary sequence, you might see locally the preservation and the development of gravens, small gravens we might call, associated to with basement fault tectonics, where we believe we have preservation of pre-Eocene sediments and possibly Cretaceous strata. This seismic line, located a little bit further to the east in the province, also shows the main character. As I said, it's a very wide marine platform, full mostly with Miocene sediments, with very small or very light structural deformation, and characterized toward the base or toward the bottom of the sedimentary section by block tectonics with preservation of pre-Eocene sediments. In here, we might also observe toward the central and the left part of the image, the development of the frontal compressional fault belt associated or that is formed by the oblique convergence movement between the Caribbean and the South American plate. So it's a truss belt, heavily deformed, but it's very narrow and well developed. And finally, toward the extreme left of the image, we might see the foreland, that is preservation of Miocene and possibly Oligocene sediments, and a thin Cretaceous condensed section toward the bottom, preserved over the oceanic crust or basement. If we move further to the central part of the area, we go into the Tairona province, that essentially is dramatically different from the previous one, in the sense that in this area is, as we saw in the previous seismic line, is dominated by huge basement paleo highs, restricting heavily the distribution of the sedimentary sequence and restricted it to a much thinner section as compared to the previous deposenters. This is a regional seismic line that is roughly north-south, and where you see the Carpintero and Chimari paleo highs dominating more than half of the seismic line. And finally, toward the left, that correspond to the north part of the seismic line, we have a light compressional deformation of the Miocene section over the oceanic crust. If we take a look of a strike line, this is a regional, roughly east-west line, where you see also the strong dominance of the basement highs across this tectonostratigraphic province, as compared to the extreme right of this seismic line, where you start to see the edge of the huge deposenter that is the Chimari province. Finally, if we move into the Chimari province, this is a very interesting area in the sense that it has a preservation of a very thick and wide marine platform with tons of traps being developed by the interaction of a strike-slip, slight compressional stresses, but lots of extensional stresses and development of normal listric faults. This, as you might see, is a very thick sedimentary sequences reaching more than 20,000 feet plus, that has preserved not only the Miocene by a very well and thick Oligocene section and a very well and developed Cretaceous and Pre-Eocene sequences. This line is a strike line, roughly east-west, where we can see the same character. We have toward the top, from left to right, a very wide marine platform with prolific and very common listric normal faults. And toward the base, we have a very well developed block tectonics, basement block tectonics, with a series of grabens and horsts that preserves not only the Oligocene, but the Cretaceous and the Eocene section. Reviewing the stratigraphy, we essentially gather all the data from the few 42 wells that we mentioned earlier. This is a well penetration summary chart where we try to summarize all the penetration, all the series of sequences, stratigraphic sequences that were penetrated by the different wells in the area. Essentially, it's important to highlight that the integration of these, rather sparse well data with the seismic, what we try to do is to present a summary or series of paleogeographic maps that indicate the distribution of the possible sandstones and carbonates that might act as reservoir rocks in the area, but also the distribution of the different units in the area. And this is a summary of the different maps that we did for the area. They are, of course, not reconstructed, they are not true palimpsestic maps, but they are, rather schematic paleogeographic maps. It's important to highlight that in the area, in this base map, in the southernmost part, we have the Guaitapa and the Manantiales wells. In the easternmost part of the onshore Guajira, we have the Guajira 1 well. And finally, toward the north, in the offshore area, but relatively close to the shoreline, we have finally the San Jose wells. We want to highlight these 4 wells because those are the wells that have well data that evidence the presence of the Cretaceous and the Eocene sequences in them. The San Jose is one of the most important wells in this regard, and it has a thick section of Cretaceous sediments overlapped by a thin Eocene preserved data. The Guajira 1, that is the one that is in the northern part or the easternmost end of the Guajira Peninsula, also have preservation of Cretaceous sediments, although here we might recognize that the evidence is not as clear as in the San Jose well. Then, let us share with you quickly what we mentioned earlier, that the hydrocarbon shows are very common in different sequences. We are gonna walk here from the Oligocene and to the shallower section. And here we are highlighting all the shows, mainly gas shows that we have in the different wells, not only and the type of reservoir where they were present, in either sandstones or carbonate units. Here we are sweeping toward the younger part of the section. Here you see the preservation and the very good oil shows, for instance, that we have in the Santa Ana 1 well. As we move further up, we have the gas shows that we have in the Santa Ana, in the Molusco wells, and in all the Tinca, Luchara, Efrin, and Sorpresa wells that are in the carbonate platform strata. As we move further up in the stratigraphic section, most of the gas shows are now preserved to the west wells and in the offshore area, but close to the shoreline. Then, if we move to test data, we also show in the same stratigraphic sequence. Here we are starting with the Oligocene data, where we have gas tested in the Orca well and in the Guajira well. As we move higher in the section, we have a wider distribution of testing of gas, and of course is the testing and of course the very well-known production, huge production from the Chuchupa and Ballenas fields. And as we go higher in the section, we have this distribution in the Santa Ana, Cocinetas, and Almeja wells. As we move to younger strata, we have a wider distribution of gas test, again in the western and southern carbonate platform that is located in the shallow offshore and in the onshore area of the Guajira. Finally, we go to the very young sedimentary sequence of the uppermost Miocene and Pliocene. Now, based on all the seismic integration of what we said, that we interpreted around 45,000 kilometers of 2D seismic, we compile a series of structural maps, both in time and depth, that were used, as Cesar will show us in a minute, the regional integration and all the petroleum system analysis. This is, for instance, an example of the basement map in the local area in the offshore in Guajira, where we take a look of a more regional picture in not only showing Guajira, but also showing the Gulf of Venezuela. This is the structural map for the basement, where you might see an important feature here, and is the epicenter that you see toward the right of the image. This is the epicenter that is developed in the Gulf of Venezuela, where we have a clear evidence of preservation of most of the Cretaceous prolific source rock that is associated with the huge volumes that we have of gas and condensates in the Perla field in the Venezuelan side, meaning that the onshore area and the coast and the going up from this epicenter toward the west, we have an area that have a huge exploration prospectivity indication. Finally, as we mentioned, we found in the area lots of different type of traps, both structural and stratigraphic. This is a deep section, roughly north-south, north toward the left of the image, where you might see how abundant is the development of normal listric faults along this section. That as you know, in the Gulf of Mexico or in the Niger Delta, all these type of structures are very prolific in exploration and production. Also in this section, you might also see clearly toward the bottom the development of block tectonics, including the basement, and of course covered by Cretaceous and Oligocene strata that has not only the source rock, but also abundant reservoir intervals. In this seismic line, there is also a deep line located toward the west part of the section. We have a very nice image of the very abundant compressional, what you might call snakehead faults, associated to a very well developed compressional or thrust fault belt in the area. Also, toward the left of the image, we might see the type of structure, positive flower structures that are being clearly developed in the foreland, associated to a strike-slip movement in the area that is very, very common and very highly impact in the area, as most of the area has a strong lateral movement between the Caribbean and the South American plate. Then if we go, here is another example of those positive structures associated with the strike-slip tectonics. We also have rotated blocks associated with the basement block tectonics that we have that is very common in two of the provinces in the basin. We have also very common and very prolific stratigraphic traps. As we have seen in the different seismic lines, we have a very wide and very well developed marine platform that has clearly developed of progradational sequences, as you might see in this image in the upper right, in the upper left part, where we might find either basement or basal development of sandstones in the toes of the clinoforms, and also the development of sandstones along the very strong progradations that we have in the area. The second and very well-known type of stratigraphic trap that we have in the area is the development of carbonate bodies of lower Miocene in age that are development over the wide marine platform that was developed in the early Miocene. That this is one of the most hunted place in the area. Here we have another type of stratigraphic traps associated to the block tectonics and the development of gravens and horst that we have. And on top of the horst, we have the common development of high energy marine sandstones and high energy marine carbonate units. And we also have a very strong potential associated to the on-lap around these paleo highs. Finally, we have, of course, a series of mixed traps. For instance, the development of paleo highs on carbonate preservation on paleo highs, the development of Miocene, early Miocene sandstones over the sandstones or over the basement highs, where the energy was high enough to preserve the coarser sections. We have the Oligocene sandstones over the highs and also on laps over the basement highs. And finally, the sandy filling on the pull-apart basins that are formed mainly in the Chimari section, in the Chirinche province, sorry. And also have the half gravens and the sandy fillings of the block tectonics. At this point, I'm gonna give the presentation to Cesar for him to show us the results in the petroleum system analysis.
Thank you, Juan Carlos. Good morning, everyone. First, I want to thank the ANH for this opportunity, and also a special thanks for the Pamplona University. For Oscar Castellanos and his group was really good to work in this project. I'm going to share the PowerPoint. And we are going to talk in the next minutes about the petroleum system modeling. On that topic, we will be including the petroleum geochemistry. And also we will talking about plate fairway maps, and finally about the jet to find. First point we have here is related with the hydrocarbon occurrence. As you know, for so many years, maybe 40 years, the exploration activity in the Guajira basin, especially in the offshore basin, was related with the classification of this gas, the gas that was found by Texaco in Chuchupa and Ballena. Because from the beginning, they talk about a biogenic gas. Then it wasn't really good for the exploratory activity in the basin. It's not easy to define the prospectivity in a regional context when you have a biogenic fields or a biogenic petroleum system. Then this start to change 20 years ago, 22 maybe years ago. And right now we have this summary about the shows we have in the basin. And I believe that we can say today that this is a thermogenic province with all the spectrum of the hydrocarbons we can find in the oil window and in the gas window. First, we have the Chuchupa and Ballena fields, maybe 7 TCF of gas, 98% of methane. Then we have shows of gas in Santana, and we have gas in Orca, probably the last discovery in the basin. Additionally, we have in all these points, the orange one, we have evidence for hydrocarbons that were present in the piston core samples. That's very important for the basin. I'm going to show you some results. Then we have the only oil that we got from the subsurface was present here in Calamar 1. In Cuttings was recovered condensate hydrocarbon. And finally, we have Perla field. We are going to talk a little bit about Perla because we are sure that this is very important for this part of the basin. And we need to include Perla and the relationship that field has with the petroleum system and the prospectivity in this northern part of the basin. Now we are going to see a summary of this thermogenic evidence. First, we have here an example of why during 40 years people was talking just about biogenic system. It is because the gas from Chuchupa and Ballena is 98% methane. And also because the isotopic composition of that methane is between minus 50 and minus 60. But it's interesting that according to this classical interpretation, the Church interpretation was the classical interpretation for the last century, this is a mixing area. But even with that, Texaco was talking always about biogenic. According to that interpretation, we have biogenic, but also we have a mixing. And a mixing means we have some gas that is coming from a thermogenic system. This change at the end of the century, of the 20th century, related with a research that was developed in the IFP. And according to this research, it's possible to get that kind of composition from a different processes. And that process is called secondary cracking from oil. That means we can get a gas 98 or 99% methane with a very light isotopic composition just because the maturity level that is too high in the podaptid of source rock, and especially because in the source rock we have a secondary cracking processes. That means the oil in the source rock is cracking or were cracking to gas because of the temperature, because of the burial history. And this changed everything. These results were getting by Ecopetrol 20 years ago. And using that information, Ecopetrol designed a piston core survey that was made in maybe 2007, maybe. I'm not sure now. And Ecopetrol get very, very, very important information. Here we have a summary of that. The first one is that most of the gas they got correspond to a typical thermogenic gas with a heavy isotopic composition. And that gas are related with a condensate thermal maturity. We don't have for that gases the option to interpret that as a secondary cracking. It's just a thermogenic gas. That's the main point that is very important for that survey. The second one was the presence in so many of the samples and the presence of diamondoids. Diamondoids are geochemical compounds related with a thermogenic process. They are related with the last part, the late oil window. We need that kind of maturity level in order to have diamondoids. And according to that results, we have at least two trends in the basin, and that is a proof of the thermogenic system. It's not possible to have that kind of concentration in ppm of diamondoids from a biogenic processes. That means we need a source rock with enough maturity level in order to create this kind of compounds. That's the second one. And the last one, obviously the most important, is that was possible to get in the piston core samples some black oils. Here you can see oil correlation, biomarker correlation between one of these black oils with Cretaceous oil from Gulf of Mexico, and another one coming from La Luna, oil from La Luna formation, related with La Luna formation in Middle Mac. You can see the correlation using the biomarkers that we are showing here, a correlation that suggests the presence of a source rock, a Cretaceous source rock, in a maturity level that could explain that black oil. Additionally to this, we have in the PC surveys from the last 10 years, a lot of evidence also about thermogenic hydrocarbons. For example, we have samples with a very high UCM, a very high amount of bitumen of hydrocarbons recovery in the samples, and these samples also have a very high values of TCF, total scanning fluorescence. That means this must be thermogenic. It's the same situation here. This is for another survey. And also here, this is for another one. We have then in this PC piston core surveys, we have a lot of evidence. The gas in a lot of samples has that signature from the thermogenic systems. According to that, we can say that we are in a thermogenic province, and probably this is one of the most important points, is that in Calamar 1, which is located here in the southern part of the bay on the Guajira offshore, from Miocene sequence, was possible to get a condensate. Here you can see how we see these hydrocarbons, and here you can see the gas chromatography, very typical for condensate. This is not possible in a biogenic system. This is a liquid hydrocarbon that could be related with a source rock into the oil window, into the late oil window. According to this information, we believe that this is a good time to stop talking about biogenic gas as a main target for this basin. I think it's a time to stop with that. Biogenic is there. We know that. Biogenic is there. That's not the problem. But we need the thermogenic system if someone wants to get enough hydrocarbons in order to be commercial at discovery in the basin. Let's start talking about the Guajira offshore as a thermogenic province, like and others we have in the country. Finally, we are going to talk a little bit about Perla. Here we have this map. Here you can see our Guajira province, the Urumaco Depot Center, which is going from Venezuela to Colombia. And in this high, we have Perla. What we have in Perla? First, we have a huge accumulation of gas, very close to 14 TCF. And this gas is from primary cracking. Remember that the gas from Chuchupa and Ballena was here, very close to the final part of the secondary cracking. But this gas is different. The maturity level is lower than this. And because of that maturity level, which is lower, we have condensate. this is a field with maybe 150 million barrels of condensates. Then here we don't have that discussion. This is a thermogenic system. Why we have this kind of gas and this kind of condensates different than the gas we have in Chuchupa and Ballena? Probably is only related with the maturity level of the source rock into the depot center of Urumaco. Here is lower, that maturity level is lower than the maturity level we can see in the Tayrona depot center. Okay, now we will be talking about petroleum geochemistry, about source rock evaluation, and the results here is very simple. We don't know the source rock. We don't have data in order to prove the source rock, and it is because the stratigraphic penetration of the wells. Here you can see we don't have too much hydrogen. Those data are from the offshore basin, and those are from onshore. But anyway, here we can see that we don't have hydrogen, we don't have too much organic content, and then we don't have a good genetic potential. Most of this information is coming from Miocene, from the Miocene sequence. Some samples from Oligocene, and that's all. We don't have information about Cretaceous or maybe Eocene. And especially for the Cretaceous section, I believe that will be very difficult. Probably this could be a basin when we are going to get oil without to know directly the source rock. It is common in some basins, in so many basins in the world, especially because the source rock is too deep, is located in a position when you are not going to drill any well. Then now we are going to present the results for the petroleum system modeling. We did 1D modeling and 3D modeling using the structural maps that Juan Carlos was talking. For the 1D modeling, we use a well into the onshore area, Epejin, or we have another one in the offshore, San Jose, and a pseudo well in the deeper part of the depot center here. You can see here this structural section. Here we have the pseudo well, and in this graben, we are including this Cretaceous source rock according to the seismic interpretation, but also according to the presence of black oil that are related with source rock intervals with Cretaceous source rock intervals or Cretaceous source rock depositional environments. Then we have Epejin here in a thinner sequence. And between these two, we have San Jose. This is located more or less in this part. But on that part of the basin, we have also the Cretaceous and the Eocene sequence. Here we have the results. First, for the onshore well, the sequence is immature. That's the result. It's easy to understand why this is not enough burial to get the maturity level to explain oil. It's immature or early generation, the sequence there. Here we have San Jose, and in San Jose, including the Cretaceous, we can see that Cretaceous is at the beginning of oil window. That means San Jose is very close to the boundary, to the upper boundary of the oil windows. And according to that model, for San Jose, we have a maximum vitrinal reflectance around 0.8, maybe 0.75. And we have a transformation ratio about 70%. And here we can see expulsion pools located during the Pliocene. That means for that pools, we was necessary to complete the deposition of the Pliocene sequence We need the Miocene, we need the Pliocene in order to get the maturity level to explain the oil and to explain the gas. And for the last one, which is the deeper one, the pseudo well one, you can see here the results. On that part of the basin, one of the deepest part of the basin, we can get a very high maturity level into the late generation with a maturity, with a vitrinal reflectance around 2, maybe 2.2 maybe, with a very high transformation ratio, very close to 100. That means right now on that part of the basin, the source rock is spent. It is a spent source rock. And then we have these hydrocarbon expulsion pools that is early that the process we see in San Jose. This is located more or less in the middle Miocene. That's very common. The expulsion processes start in the middle Miocene, in the deepest part of the basin, and is getting younger to the end of the productive of source rock. How we see this in a 3D basin modeling? Here we have the basement structural map. We can see the depot centers that are really very important for the basin. And we can see the Carpintero hike, which is a very, very huge structure, very huge structure. An important point, we are going to talk about that at the end. Look at the number of wells we have in the Carpintero is really very, very small, the amount of wells. And a lot of the hike wasn't drilled until now. That means that's a very good opportunity for the basin. Here is the structural map for the Cretaceous. We can see that in this geological province, we have the Cretaceous just in the Gravens, as Juan Carlos showed you. But in the northern part, in the northern province, we can see a higher distribution of the source rock. This is very important because now I believe that this is one of the main points from this project. We can define a higher prospectivity for this part of the basin. I'm going to show you why. This is the result in terms of maturity level for the Cretaceous section. Here we have the Gravens, and we have this section here with the Cretaceous in the deeper part. And here we have two maps, maturity vitrinite reflectance map for 7 years ago. And here you can see that at that time, Upper Miocene, most of the northern part was into the oil window, the green colors, early generation and late generation. And just in some parts, especially in the southern part, we had the Cretaceous into the gas window. And this is the map for the current situation. You can see the change. All these depot centers, all these Gravens right now has the Cretaceous into the gas window in a very high maturity level. But in the northern part, we have all the sequence. We have early generation, late generation, early gas window, and late gas window. This is very good for that part of the basin because on that area we can have the best opportunity to get liquid hydrocarbons related with this distribution of the maturity level, the hypothetical distribution of the maturity level for the Cretaceous source rock. Here we have the transformation ratio for that unit. The red color corresponds to a transformation ratio higher than 80%. Most of the area and on that situation right now. And all just in this northern part, we have a transformation ratio lower than 88%. Here we have the amount of oil expulsed. You can see the amount uh, is more than 10 million barrels per square kilometer, which is good. It's very good. In the middle mark, for example, we can get something around 15 in the base areas. Then this is very, very similar. This huge amount of expulsed in oil is important in order to explain the mass balance calculation we have at the end of the talk. And this is the amount of gas, which is also very, very high. You can see that the red colors correspond to maybe 30 BCF per square kilometer. And this area, the northern, is between 10 and 20 BCF per square kilometer, which is a very good amount of oil and gas expulsed from the Cretaceous or rock. Next step was to work in the migration pathway model and in the hydrocarbon charge model. And we did that exercise for two sequences, for the Oligocene one, the sequence 7, and the early Miocene, the sequence 5. Juan Carlos was talking about that sequence and he mentioned that those sequences are the main reservoirs in the basin. The people in the project got the main results in the reservoir evaluation for that units. That's the reason we concentrate the work on that. You can see the migration patterns, and you can see also a lot of accumulation, a lot of closure, structural closure that in some cases has oil and in another has gas. Why we have that? It is because, especially because the PVT conditions that the software can calculate for every one of these traps. Finally, for that unit, we define these Playfair waves related with these areas where, according to the modeling, we have a very good concentration of migration pathways or even an accumulation like this that you can see here. The other point that is included here is the paleogeographic distribution of the sequence in order to include the probability of the reservoir. And here we have five Playfair waves, two related with the belt, with the Caribbean deformed belt, one in the northern part and the other in the southern part. This that we are calling Orca Santana Playfair way is very, very, very important because we have oil and also we have gas for that unit, for that reservoir. Here we have another one related especially with the stratigraphic traps that Juan Carlos was showing. Here we have that option because of the way this unit is doing unlapping over the basement. And in the southern part, we have this Playfair wave related with accumulations similar to the Calamar structure. Now we have the results for the sequence 5, which is the early Miocene, which is the main reservoir here. Again, you can see the migration patterns here. You can see something like this, a huge concentration of the migration pathways in this kind of areas. You can see right now we can see more gas than oil probably, and it is because you are in a shallow reservoir. Then the PVT condition is changing. Look at here, the software calculate for this structure, the chuchupa gas on the trap, but it is not because that gas is coming from kerogen type 3. Nothing to do with that. It is just because the PVT condition of this trap. and also for this and this. If you compare this map with the first one, you can see the change from oil to gas. And if you go with shallow reservoirs like middle Miocene or maybe Pliocene, the chance for oil will be lower, and probably you are going to have a chance mainly for gas. And using that information, using that migration and charge maps, we define these play fairways. Again, we have these two related with the belt, with the Caribbean deformed belt. We have again this for Orca and Santana area, which is a very important play fairway. We have this for the stratigraphic possibilities. You can see here this huge area where the migration pathways are concentrated to the basement. And also we have this where we are including the Guajira onshore, the lower Guajira in the onshore basin with some accumulation that could have gas. Finally, we did an exercise about the unexplored sectors. The first point with this is, again, we are going again with the Carpintero High. Here you have the relationship between the structural map of the basement, the migration pathways. You can see here the migration pathways going to the high, and also you can see the wells we have. We don't have too much wells. We have a huge area where we don't have wells, and where we believe this is a very good opportunity to find oil. And finally, this is a summary of the polygons that we call unexplored. That means these areas are included in the play fairway map, but we don't have wells here. That's the reason we call these blocks as unexplored sectors. If you compare the amount of area that is unexplored with the size of the basin, is a huge relation. We have a lot of area again where we can development. Probably the best option, and it's another message from here. The best option is trying to be close to the Carpintero High, because not just because of the petroleum system model, not just because there we have the main option to get oil, but also because the bathymetry that will be related with the economy of the projects. Okay, finally, we have the yet to find exercise. We are changing a lot the yet to find, the yet to find we had from some years ago. And it is because we have now the definition of this productive of source rock. We have these three areas, and now we can calculate better the data, the input data for the mass balance calculation. And according to that, we have a prospective resource very close to 23 billion barrels of oil. It's a huge amount of oil. From this kind of maps, we calculate something like 13 billion barrels. Then, according to this mass balance, we have enough oil to get to drill the main opportunities, the main traps we define in the project. Here we have a summary of the conclusion. The first point is that we include in a model with a Coniacian Santonian source rock. We have to include it in order to explain the the oil, the black oil we have in the basin, and also because we have Cretaceous rock to the north in the Columbia Basin and to the south in the Cesar Rancheria and Sinú San Jacinto basins. The basin modeling indicate that the Cretaceous source rock reach hydrocarbon generation and expulsion only in the Guajira offshore basin. It is important because that means we have to connect any prospect in the Guajira onshore probably needs to be connected in terms of migration pathway with the offshore. The maturity range for this hydrocarbon, for this productive source rock, range from 0.6 to 4 of bituminite reflectance. The expulsion peaks for the Cretaceous source rock are related with the Miocene, middle Miocene to Pliocene probably. With this model, we can explain the hydrocarbons found in Chuchupa Ballena, Orca, Santana 1, and Calamar 1. And also we can explain all the thermogenic shows, all the thermogenic evidence we found in the piston core surveys. The migration modeling for sequence 7 and 5, remember that correspond to Oligocene and early Miocene, allow to identify a significant number of traps, charges with oil and with gas. We have at least 5 play fairways areas for every one of these play fairways. And finally, we believe that we have enough hydrocarbon to discovery in the basin. That's not a problem on the basin. We have enough, at least for the main structure that we can define right now using this model. Okay, we want to thank everyone for the time, and if you have questions, we can try to resolve by using the chat. Thank you very much.
Thank you, Cesar, for this amazing presentation. Again, thank you to Juan Carlos. So now it's the time for reading comments, questions that maybe we could answer to the people that has been asking. So I like to read a comment by Mario Andres Pachon that he says, "Good morning. It's an excellent effort by the ANH to promote the exploration in the country. However, meanwhile, we keep having just the perspective or the geochemical perspective of one person of all the basins. It will be tough to get to new ideas. 50 years of exploration shows that this kind of basin, as the Guajira, but it seems that all the work, Shell, Chevron, Exxon, Repsol, Petrobras, Ecopetrol, they have been mistaken. There is a comment by Luis Ardila that he says it's not just the perspective of one person. It's the result. Okay, it seems that there is a sort of comments there that they are talking just about if there's the perspective. I just like to thank Cesar, to Juan Carlos, and maybe ask, there's a question by Mari Regosa. She got a question for Juan Carlos Ramon. How many plays related to limestones were identified at the tested play in Ballena?
Well, essentially, unfortunately, for this study, we didn't have data available from the producing wells, as there is some restrictions of confidentiality data. However, in the platform area, we were able to identify at least 2 different plays associated to the carbonate buildup over the marine platform.
Okay, thank you. If there's another question, we would like to read it. There's a question by Edgar Bueno. The east part of the offshore, next to the border with Venezuela, there is no analysis. Why? Is there more information? It is very important. It is a very important area considering the proximity to Perla. I'd like to ask this directly to Juan Carlos.
Yeah, that's a very good observation. And unfortunately, that is the case. That area has very few seismic lines and essentially 2 wells in that portion of the basin. But that's an area that we consider that is worth taking a second look, given well, of course, the results of Perla are important, but mainly is that the same source deposit that generates all the gas and huge amount of condensates to Perla might have a migration toward the west, and of course toward this onshore area in the Guajira.
Okay, we got another question by Marcel Chin Alien.
Daniel,
yeah,
I'm sorry. I want to say something about that, the Edgar question.
Okay.
Really is very important, that area, especially for all the reasons we discuss here, but also because there in the northern part of the Guajira, we have in the surface a very huge sequence of Cretaceous rocks. And that's the only part, probably the only area where we have that section. And that section is very similar to the section that was drilled by PDVSA in the PG1 well, very close to the Guajira area. Then I'm agree with this analysis. We need to improve the information there, because we have everything there. We have gas, we have condensate, and we have the Cretaceous in the area, but we need to improve the data in order to complete the models.
Okay, Cesar, there is a question of how the results of the Aruba offshore wells does fit with the results of Ecopetrol. I don't know if you got any idea about the Aruba.
I don't know that results. I don't know.
Okay.
I don't know either.
Okay. And Edgar Bueno says that probably NH must drill a new well on the area. That's quite correct. The NH during the past years had the idea of drilling a new well at the Guajira area. So if there's no more questions, I like to invite all the people and attendees next week that we will have Aruba Offshore is the extension of your own area study, just east. Okay. I like to invite all the people next week on July 23rd. We will have Putumayo Basin. On July 30th, we will have a Cesar Rancheria Basin. And the last talk of the series of talks that we love the effort of the NH, we have tried to bring with the best quality and the best speakers to all of you. We'll have on the 6th of August about conventional resources and not conventional resources at the yet to find. So we like to all of you to be like aware of these dates, to attend to these magnificent talks. So I like to thank from part of the ANH to Cesar Mora and Juan Carlos for today's presentation. Damian Cárdenas do Guerrero asked about was in a 2-hour event. Not today. Most of the presentations are a 2-hour event, but today is a more brief one that we had just the talk of Juan Carlos and Cesar. And again, I'd like to thank you, both of you, and I'd like to thank all the attendees today for the presentation. And any question that you have, do not hesitate in ask directly to the email of the ENH. And you know that at the webpage of the ENH, you can find all of these talks that have been posted even in the ENH YouTube channel. So thank you to all of you and see you next week.